Okay, so yesterday we came across the concept of motion, right? We discussed that motion and rest are to be studied as a broader term in the form of, yes, mechanics, right? And then we discussed that mechanics consists of two parts. One is, anyone? Dynamics and kinematics, right? So we are discussing kinematics. Is that fine? So in kinematics we'll be discussing motion without its cause. We'll not be discussing the cause of motion. Is that okay? So then we came across vectors, then we came across scalars, and we took some parameters of motion like speed, distance, velocity, isn't it? And displacement as well. So displacement gives the effect of motion, whereas distance gives the actual path. Is that fine? Okay. Now, and we even tried to solve some numericals yesterday, right? We discussed some numericals based on speed, velocity, distance and displacement. Today, we are going to discuss the next important parameter to understand the concept of motion, and that is acceleration. Can anyone tell me what is acceleration? Yes? We solved these numericals? So here it is. The concept of acceleration. Can anyone tell me what is acceleration? Yes? Yes?
The change of speed or direction of.
Yeah, you can say. Yes. Anyone else? Yes? See, understand. When we talk about acceleration, this is defined as the change of velocity per unit time. Okay? So up till now what we discussed was change in displacement with respect to time, and we found velocity. Now when that velocity changes per unit time, we can say that change of velocity results in something called as acceleration. So acceleration is the rate at which velocity changes. Is that fine? At what rate? For example, there was a body whose velocity was say 20 meter per second, okay? Now after 5 seconds, its velocity is 40 meter per second. What is the total change in velocity? Yes, it is 20, but this change took place in 5 seconds, isn't it? Per second, can anyone tell me how much change was observed in 1 second? Yes, for example, you have a box, okay, you have a body which is moving with, say for example, 20 meters per second, okay? Now after some time, for 5 seconds, the velocity of this body is 40 meters per second. And the time that has occurred is 5 seconds, okay? The question is, what is the change in velocity? Yes, exactly. See, the change in the velocity has changed, okay? So understand, whenever there is change in velocity, then only we can talk about acceleration. Is that fine? If there is no change in velocity, we cannot talk about acceleration. Clear? So, 20 to 40, yes? The change in velocity is equal to 20 meter per second, isn't it? But this change has taken place in how much time? 5 seconds. The question is, how much change will you observe in 1 second? Isn't it? In 5 seconds we see 20 meter change, okay? So in 1 second the change that you will observe will be 20 divided by 5, isn't it? Now this is called as the acceleration. Is that clear? Is it clear? So acceleration is the rate at which velocity changes. Clear? Now you need to understand that velocity is a vector quantity, isn't it? So the change in velocity can be of how many types? How can velocity change? Can anyone tell me? Yes? we talk about acceleration, and I told you it is the rate at which velocity changes, okay? But the question is, how will you change your velocity? Do you know velocity is a vector quantity? Yes? Isn't it? So can I say velocity has magnitude? Can I say velocity has a direction? Yes? Understand, very important thing. There can be a case in which the velocity is changing but only in magnitude. Only in, for example, there is a box and this box is, for example, at rest, the velocity is 0, okay? And after some time, I am applying some force to it, due to which its velocity increases and it is, say, 5 meters per second. Okay? And when this force is again applied to this box, what happens is its velocity reaches, say, 10 meters per second. The direction of velocity here was towards x, positive x-axis, isn't it? The direction of velocity here as well, it was again towards what? The positive x-axis. Has the direction of velocity changed?
No.
What has changed? Only the magnitude, isn't it? So velocity has changed, but only in magnitude, not in direction. At this time, we will have acceleration. Is that fine? Sometimes what happens, for example, we talk about a circular motion, okay? For example, there is a body, it is the center, and the body is going clockwise. Is that fine? Can you tell me, if I ask you, what is the direction of velocity at point A? Yes, it is tangential always, okay? So at this point, the velocity will be something like this, isn't it? Isn't it? Say, for example, the body was going with 5 meters per second. Is that clear? At this point, what is happening? The velocity is towards the positive x direction, isn't it? And the magnitude is 5. Now, for example, after some time, the body reached point B. And what will be the velocity at B? Yes? In which direction?
Down.
Exactly. So the direction is down. But the magnitude, for example, is again 5 meters per second. That means the body is in uniform circular motion. Which kind of motion? Uniform circular motion. Is that clear? See, understand. Has the magnitude of velocity changed? No. What has changed?
Direction.
Only the direction. Again you will see acceleration. Because what is acceleration? Yes, it is the rate at which velocity changes. So velocity can change in multiple ways. And if you observe keenly, in the first case what was happening is, I am applying force along the direction of motion. Isn't it? Or, for example, tell me if there was some other force, in this direction, okay? In this direction. So the velocity, if it was 5, after some time, what will the velocity be? Will it be less or more? Less, of course, because you are opposing, right?
Yeah.
So, for example, when this purple force was applied, so the velocity after some time will be only 2 meters per second, okay? The magnitude of velocity has changed, but the force is applied along the line of motion, isn't it? Here, understand, very important thing. The magnitude of velocity at each and every point, for example, after some time the body is at C. Now the velocity will be something like this, isn't it? And let it be again what? 5 meters per second. Is that clear? Is that clear? So understand here, the direction of velocity is changing at each and every point. This motion, in which the magnitude of velocity will remain constant and only the direction of motion is changing, this motion is called what? Yes? Uniform circular motion. And you are seeing that again, velocity is changing. It is not that velocity will only change in magnitude. Velocity can also change in direction. Understood? For example, you are going in a car, okay? You're looking at the speedometer and the speed is 100. And all of a sudden there is a curve. Do you decrease your speed?
Yes.
Yes? So the magnitude changes. Direction also changes. So there can be a case when we are having what? A body in which magnitude and direction of velocity continuously changes. Okay? That will be the case of a non-uniform circular motion. But again, we will see there is acceleration. Is that fine?
Yes.
Have you studied projectile motion, anyone?
Yes.
Any idea about projectile motion? See, I'll tell you. See, understand. In this case, the force was applied along the line of motion, isn't it? But in this case, can you tell me what is the direction of the force? No, here it is not tangential. Here it is not tangential. Why? The reason is, if it was tangential, understand, if it was tangential, then you are applying some force like this. Will the velocity be only 5? No, it will increase. Correct? So, understand what is happening. The body wanted to go like this, but then there is some force which wants to drag it down, isn't it?
Yes.
And due to which what happens is, the body neither goes down nor goes straight. It goes through the resultant path. Understood? So, there is some force which is actually in this direction. The body wanted to go like this, isn't it? But this force wants to bring the body down, and due to these two forces, the body goes through what? The resultant path. Is that fine? The effective path. Is that clear? And that effective path is something like this. Is that clear? Is that clear? So, this force is directed towards the center. Here as well. Here as well. The body wanted to go like this, along the negative x direction, isn't it? But then there is a force which wants to take it towards the center. Okay, so what is happening? What is happening? The body is neither going towards the center nor is it going towards tangentially. Okay, so what is happening? It is going through the resultant path. Is it clear?
Yes.
Do you understand it now?
Yes.
So this force which is directed towards the center at each and every point is called as, very good, centrifugal force, isn't it?
Yes.
Now understand, in the first case, velocity was changing only in magnitude, only in, when this is the case, remember forever, the force is always parallel to velocity. Is that clear? Is that clear?
Yes.
When the magnitude of velocity changes, the force will always be what? Parallel to velocity. Is that clear? Is that clear? But now see here what is happening. The magnitude remains same, isn't it? What changes? The direction. So in this case, when only direction changes, magnitude remains constant, remember for the rest of your life that force will always be perpendicular to velocity. Is that clear? Is that clear? So if from today onwards someone tells you there is a body on which force is in perpendicular direction to its velocity, what will change? Yes? Direction of motion will change. If there is a body in which the force is parallel to the velocity, what will change? Yes? Magnitude. Is that fine? Either it will increase or it will decrease. Is that clear? Any doubt? Write it down. Write it down. When force acts perpendicular to the direction of motion, when force acts perpendicular to the direction of motion, only the direction of velocity changes. Okay? When force acts perpendicular to the direction of motion, only the direction of velocity changes. Is that fine? And if force is parallel to velocity, and if force is parallel to velocity, okay, then only the magnitude changes. Only the magnitude changes. Is that clear? So how many of you have observed projectile motion before? Is projectile motion something like this? There is x-axis. There is, say for example, y-axis. And what you do, you throw a ball, okay, obliquely, and let this be like this. Isn't it? You've seen it? Now understand what is happening. Now understand what is happening. You try to throw the ball like this, so this is your velocity, isn't it?
Yeah.
Let the angle here be theta. Okay? Can you tell me what will be this component? Yes? Can I say this is the horizontal component? Can I say this is the vertical component? Yes? Now understand. There is only one force which is acting on this body. Which is that?
Gravitation.
Exactly, that is the force of gravitation. That is the force of gravitation, okay? And that force is always like this, is it? Is it? Now tell me, this gravitational force, is it parallel or anti-parallel to Vy? This force. Is this parallel or anti-parallel to Vy? Anti-parallel means opposite direction, but along the line. Doesn't this Fg act like this? At every point, Fg is like this, isn't it? At this point, Fg is always like, isn't it? So this force, Fg, the gravitational force, is acting along the line of Vy, isn't it? Is that the first case? In which we said, when the force is along the line of action, what will change? What will change? The magnitude. Isn't it? We just understood it here, see? You are applying some force in this direction. So velocity is increasing. You are applying some force in this direction, opposite direction. The velocity will decrease. So when force is parallel or anti-parallel means opposite. Direction is opposite. Okay? So when force is parallel or anti-parallel, we are seeing that the magnitude of velocity changes. Is that fine? So that is the reason when you talk about projectile, this Fg will change Vy in magnitude. Is that clear? Is that clear? That is why initially the velocity is maximum, but at the top you say at the top Vy is equal to 0. So what has changed? Vy in magnitude, okay? And that magnitude has changed because Fg was acting along the line and it was opposite. Is that fine? Now understand. The horizontal component Vx was like this, isn't it? This Fg, is it perpendicular to Vx? So what will change? Will Vx change in magnitude? Then direction. Is that fine? This will change the direction. This is the reason that the path is parabolic. Is that clear? So we have forces, but then we have two velocities. One force, the force that is acting, the gravitational force, is, in this case, it is parallel to Vy and it is perpendicular to Vx. So when force is perpendicular to Vx, this will not change the magnitude. When force is parallel to Vy, it will change the magnitude. So this will result in change in path, change in direction, while as this will lead to the change in magnitude. Is that clear? That is why every point, if you ask what is the value of Vx at the top, it is the same as it was at the bottom, is it? What is the Vx value here? Same. Everywhere Vx remains same. Is that clear?
Yes.
So this is the concept of producing acceleration when the velocity changes. Is that fine? Clear? Now let us come back to the concept of so when you define acceleration, what is it? Yes, it is the rate at which velocity changes. So first of all, what you need to find? You have to find the change in velocity. Okay? So acceleration will be the change in velocity and then you divide it by time. Is that clear? So change, how do you find change? Is it final minus initial? Yes. So we can write it as final velocity minus initial velocity and then you divide it by the change in time. Is that clear? So this is how you find the magnitude. What about the direction of acceleration? In which direction is acceleration? What is the direction of acceleration? Anyone? Yes?
If it's speeding up, it's the same as velocity. If it's decelerating, it's the opposite of velocity.
So from today onwards, remember, the direction of acceleration is the same as that of not velocity. Most of the students say this. You should say change in velocity. The direction of acceleration is same as that of change in velocity. Not of velocity, but what? Change of velocity. Now, that is the reason when you speed up, so the speed is increasing, okay? When the speed is increasing, acceleration will be along the direction of velocity. Okay? When you are reducing your speed, the change is negative, isn't it? That is why it's against. See, if you talk about there's a body which is going with 2 meters per second, okay? Fine. Now, after some time, it is speeding up, and now the speed is 5 meters per second. Okay? So the speed has increased, isn't it? The direction of velocity is like this, so you must have applied some force. Understand? The change will be what? Final minus? So that will be 5 minus 2, isn't it? Is that positive? Because it is positive, so the change in velocity is positive. Change in velocity is positive means the change in velocity has a direction eastwards. Is that clear? Therefore, acceleration will also be eastwards. Is that fine? So, or you can say, you can simplify it, you can say acceleration has the same direction as that of velocity when the body is speeding up. Isn't it? Speed was 2, now it is 5. When the speed has increased, we can say acceleration has the same direction as that of velocity. Why? Because actually when you talk about change in velocity, that direction is towards east. That is why acceleration will always be towards east. Is that fine? But if, for example, you have a box and it is moving with say 12 meters per second, okay? And after some time, its speed is only 6 meters per second. What is the change? Yes? Change is final minus initial. Is that positive or negative? Negative. Negative means the direction of change in velocity is westwards. Is that clear? So westwards. That is why acceleration will also be. Is that clear? That is how you can say when the body is speeding down, acceleration is against velocity. But that is a crux. You need to remember the actual direction of acceleration. The direction of acceleration is same as that of change in velocity. Write it down. Write it down. The direction of acceleration is same as that of the direction of acceleration is same as that of change in velocity. As that of change in velocity. Is that fine? Is it clear? Now we can simplify it to a concept. See, if the velocity and acceleration are in the same direction, like in the first case, the body was at 5, now it is at 10, they are in the same direction, okay? Then the object is speeding up, isn't it? Is that fine? And what about this? If the velocity and acceleration are in opposite directions, the object is? That is true. Don't take the direction of acceleration if the body is speeding up, then no. Understand the direction of acceleration is same as that of change in velocity. Is that clear? And when you talk about acceleration and velocity in the same direction, then definitely speed will increase. For example, I drop this pen. What is the direction of velocity? Down. And acceleration is also?
Down.
So it is speeding up. Is that fine? But when I throw it up, what happens? When I throw it up, velocity is? But what is acceleration?
Down.
Because the force of gravity is down, isn't it? So when it is opposite, it is slowing down. It will finally stop and then come back, isn't it? Is that clear?
Yes.
Okay, let you solve this question now. If you understood the concept of acceleration, now tell me. A family excitingly drives to Home Plus for some well choreographed shopping, okay? They want to shop, they want to make their place aesthetic, and now they are going to Home Plus to purchase some stuff, okay? For each of the following cases, determine the direction of acceleration of the car. Okay? If I ask Moin, the car travels east, okay, and it is speeding up. What will be the direction of acceleration? Exactly, right? So we have a car which is going towards east and it is speeding up. Speeding up means if it was at 2, now it is at 5, isn't it? Change is what? Positive or negative? Positive, exactly. So when the change is positive, therefore you can say acceleration will also be towards east. Is that fine? Clear? Okay. The car travels east and slows down. Yes, agreed? Exactly. So what is happening? The car is going towards east, but then it is slowing down. It means, yes, the body was traveling with 10. After some time, what is the speed? Say, for example, it is only 5. What is the change? Negative. Therefore, understand, change is negative. That means acceleration will be opposite. Is that fine? Is that clear? Okay. Next. A car travels east and with constant velocity. Yes?
There is no acceleration.
Very good. Because what did I say? The basic definition of acceleration was it is the change of velocity per unit time. But there is no change, there is a constant velocity. Okay? So when there is constant velocity, the acceleration of the body will be 0. Very good. The car travels west and slows down. Exactly. Car is traveling towards west, so car is going like this. And it is slowing down. So the change will again be negative. For this, negative is this. Understood?
Yes.
Therefore, acceleration will be eastwards. Is that clear? Very good. Car travels west and speeds up. Yes? Exactly. So when the car is traveling towards west and it is speeding up, the acceleration will also be towards. Is it clear? Is this clear? Now I have a question for you. Is it possible for a body to have 0 velocity but some value of acceleration? Yes. Is it possible for a body to be traveling with, to have zero velocity but some value of acceleration? No? Anyone? Think about it, yes?
Maybe the velocity was first 5 and it became 0, so the acceleration is...
Exactly. There is acceleration. It is possible. Understand. Remember this point. If the velocity of the body is 0, there is a possibility that the acceleration body will have some acceleration. Why? Because you again forgot the definition of acceleration. I did not say the velocity of the body should be 0. I said the change in velocity should be 0. Then only acceleration will be 0. If there is no change, acceleration will be what? This case. When there is constant velocity, we can say acceleration is 0. But when a body has 0 velocity, for example, let me talk about this pen. I throw it up. At the top, what is the velocity?
0.
Exactly, but is there 0 acceleration? No. G is always acting over it, isn't it? So remember this case. Some people think acceleration will be 0 velocity. No, it's not always true. If velocity is 0, we understand body is at rest. For example, like me. I'm here. My velocity is 0. My acceleration is 0. It's fine. But it is not always true that a body has 0 velocity and the acceleration will be 0. What is true forever is when the change in velocity is 0, acceleration will be 0. Is that clear? But if a body has 0 velocity, never say its acceleration will always be 0. It can be 0, it cannot be 0. So there is a possibility of non-zero as well. When I talk about this again. When you throw a ball, when it's at the topmost point, its velocity is 0. But then it does have acceleration. The acceleration is the change in its velocity, and there is some change, as she pointed out. If it was 5 here, what will be the velocity here?
0.
Exactly. So there is some change. And if it is 0 here, after some time, first second, it will travel again 5 meters. Okay? Is that fine?
Yes.
So there is some acceleration. The gravity of acceleration due to gravity 9.8 meter per second square. It is always there. Is that clear?
Yes.
Do you have any doubt in this? Write it down. For a body at rest, acceleration is always 0. For a body at rest, acceleration is always 0. But if the velocity of the body is 0, there is a possibility. If the velocity of the body is 0, there is a possibility that the acceleration of the body will be non-zero. That the acceleration of the body will be non-zero. Is that fine? Example, motion under gravity. Clear? Motion under gravity. Okay. Now we have understood the various parameters of motion. We discussed speed, we discussed velocity, we discussed acceleration. We know where and how exactly does velocity change. We know what is acceleration, we know what is speed, okay? Now what we have to do is, we have to combine these parameters for a body in motion. And how we do that? We use the kinematic equations. Okay? Is that fine?
Yes.
Now for kinematic equations, there are some things that you need to know. Vi will be the initial velocity. Vf will be what?
Finite.
Delta x is the change in position or a displacement when we know that, right?
Yes.
A is the acceleration and t is the time period for which the body is in motion. Is that clear? Okay. So understand, out of these 5 variables, 1, 2, 3, 4 and 5, okay, 2 things are very important. You can only use an equation when these equations are only valid when the acceleration of the system is constant. What? Acceleration of the system is? If the acceleration of the system is not constant, we cannot use these equations. Is it clear? This is the first important thing that you need to know. Because if there is change in acceleration, for example, you are in a car and all of a sudden, the brakes are applied. What do you observe? You get a jerk, isn't it? Isn't it? What is a jerk? It is a change in acceleration. And we cannot incorporate that jerk in these equations. Okay? So remember, whenever you want to use kinematic equations, acceleration of the system has to be constant. If it is not constant, we cannot do it. Clear? Okay. So, I think you have seen this equation before as well. Final velocity is equal to initial plus acceleration into time. Have you done it? Yes? Final velocity is equal to initial plus acceleration into time. No? Have you done this expression before?
Yes.
Final velocity is equal to initial velocity plus acceleration into time. See, how many variables are involved? Out of those 5, we have 4 variables, right?
Yes.
Which is missing? Displacement. So when there is no displacement, then only use this equation. Is that fine? No displacement, that means it is not given and you have to find something else. Okay? Don't use other equations. Why? Because only in this equation you don't need displacement. Okay? Okay. Similarly, there can be a case when the final velocity is not given and the other 4 variables are given. Okay? So, or you have to find one. So if no final velocity is given, then the displacement delta x is given by initial velocity into time, okay, and then add to it half of acceleration into time square. Is that fine? Similarly, when no initial velocity is given, when the initial velocity is not given, final is given, okay, in that case your delta x will be v final in times t, subtract from it half of acceleration into t square. Clear? And when time is not given, you don't have time, okay? Time is not given. So you can use this equation directly, that the square of the final velocity, subtract from it the square of the initial velocity. This will give you 2 times acceleration into displacement. Is that okay? And then you have one more modified expression, which is for no acceleration. When the acceleration is not given in the system, okay? He doesn't give you the acceleration, then directly you can find the displacement by initial plus final divided by 2 multiplied by the total time. Is that okay? These are the 5 equations. Write these down because we have to solve numericals which will be used. Out of these 5 equations, you have to select an equation that will help you to solve the system of questions. Is that fine? Have you seen these equations before?
Yes.
Have you used them before?
Yes.
So I hope you'll be able to solve numericals there. Okay? Okay, here we have the first question. What is the question? Yes? A 2014 Hyundai Elantra uniformly very important, uniformly accelerates. That means acceleration is constant. If it was not constant, we cannot use these equations. Is that fine? From 12 meter per second to 20 meter per second in how much time? So what is given? Yes? Initial velocity is 12. Final is Final is what? 20. Time is? Yes, time is also given 3 seconds. What is the question? What distance does it travel in that time? Can you solve it? Out of the 4 or 5 equations, which equation should we use? In which we don't have? We don't have acceleration. Right? So when we don't have acceleration, we can use the first directly, isn't it? Is that okay? That is V initial plus V final divided by 2. So we can say that the displacement is equal to V initial plus V final over 2 into time. Tell me the result. 48. Who solved it for 12? Initial is 12. Final is 20. Add them. That is 32. 32 over 2 is 16. 16 into 3, it is 48, of course. So the answer is 48 meters. This is the distance traveled by. Is this clear? Very basic. But you should be able to understand which equation is to be used. Clear? Copied? Okay, if this is clear, now we have a Hyundai Accent. It is initially traveling at 10 meters per second. See, understand, how do you read the question? Reading the question is also important. Whatever is given, understand how does it relate to what you know. When he says 10 meters per second, what should click to you? V initial is 10, isn't it? And write these down. Whatever is given in the system, you should always make it a habit. Write these things. Okay? So what is the initial velocity? Very good, it is 10 meters per second. It accelerates uniformly at a rate of 2 meters per second square. So what is the acceleration? So what is the time? Now what is the question? How far does the car travel during this time? So what do we need to find? How far means delta x. We have to find the change in position. Clear? No final velocity. Isn't it? So we can say, what is the equation? Yes? Delta x is equal to, yes, V initial times time plus half of, yes, acceleration into t square. Is that clear? Is that clear? So what is the initial velocity? Yes, it is 10 times time, which is 4, plus half of, what is acceleration? 2. What is time? It is 4 square. So what is the answer? Tell me the result. 40, and this will cancel. This is 16, so it is 56 meters. Is that clear? Is that fine? Just understand how many variables were given? 1, 2 and 3. So the fourth variable is unknown. And every equation uses 4 variables. Out of the 4, 1 will be a variable and 3 will be known. So here 3 were known, the fourth was unknown. You select the equation which will help you to find it. Is that clear? Okay. So solve this. The one who does it first will get a reward. Yes. 5 dirhams. Or a Costa coffee. Is that fine? If you want Costa coffee, solve this. Yes. what did I say? The first thing you need to do is write down what is given. Make it a habit. Physics always requires diagrammatic representations, and in particular when you talk about motion it is very important. Okay, so what is the question? A 2000 Ford Focus is traveling at a speed of 22 meter per second. What is the speed? 22. The brakes can produce a maximum acceleration of 8 meter per second square. Okay? So when you apply brakes, I want to ask you, what happens to the car? Stops. Does the velocity reduce? Is it? So understand. Whenever velocity reduces, the acceleration produced is called as, will the change be positive or negative? Negative. So the direction of acceleration will be against the motion, isn't it?
Yes.
So will you take it as positive or negative? You have to take it as negative. Very good. That is why this acceleration is called as retardation or negative acceleration. Is that fine? Yes?
30.25.
30.25. Anyone else? So she's the first one.
30.25.
You didn't say it. You lost Costa Coffee. Maybe. Let me check what is the answer. We can help. You can share it. Okay. The speed is 22. Is it the initial speed? Yes? The initial speed is how much? Yes, it is 22 meter per second.
Final is 0.
Final is?
0.
Very good. The final velocity is 0 because the body is going to rest. Because he says what is the minimum distance needed for the car to stop. Stop means final will be 0. So acceleration is how much? Yes, -8. Called as retardation. Is that fine? Now we have to find delta x. Now tell me what we don't have. We don't have time. Do you know the equation without it?
Yes, Vf squared.
Exactly, we have this equation. Vf squared minus V initial squared is equal to 2 times acceleration times delta x. Is that clear?
Yes.
What is the final velocity?
0.
So will this term go? Negative times V initial squared will be 22 squared. That will be equal to 2 times. What is acceleration?
8.
-8. -8. Don't forget it. Multiplied by delta x. So we have to find delta x. Yes. What is 22? So see, negative and negative cancels out. Is that fine? Or you use your calculus. So just tell me the result. 22 squared upon 2. How much is that? And upon 8 as well.
484.
484. That is 22 square.
242.
What is 242?
22 squared divided by 2.
And then divided by 8.
You want the final answer?
Yeah, of course.
30.25.
30 point? So that is the final result, okay? So the final result is 30.25. Who said it first? You? So you got Costa Coffee in the plate. Is that fine? Take it from me. Is it clear? Yes? Okay, one more chance I give. Maybe a croissant for this. Solve it, don't use your phone. First write it down, write down the equations. You do it directly over the phone? Huh? How many of you want to be pilots? You don't want to be a pilot? I wanted to be a pilot. So that I can fly the jet. Read, yes? Read. How do you write it? What is this?
No, this is
Question. You are fine. Yes. Tell me the answer. 37.6. You tell me.
For final velocity, I got 75.2 meters per second. And for acceleration, I got 30.08 meters per second.
For final velocity, you got what?
75.2.
75 meter per second. And for acceleration?
30.08 meters per second squared.
So Tagreez has come up with the result. Let's see if she is right. She gets a croissant. Have you had a croissant before?
Yes.
It is good. Okay, see. Understand the question. A jet requires 2.5 seconds. So time is given? Time is given. How much?
2.5.
Very good. Of acceleration from rest, initial velocity is? Very good. Lag. To cover a distance of 94 meters. So what is the distance? Delta x, right? Is that fine? The question is, what is the takeoff speed? See, what happens is, if you have ever been in a jet or a plane, the plane first starts and then moves some distance and then takes off, right? Isn't it? So, if it was at 0, understand the question. The question is for 94 meters, it travels. And the time taken is 2.5 seconds. So, that means this distance is how much? 94, and the time taken is what?
2.5.
Isn't it? And when it reaches point B, it gains enough speed to take off. Is that clear? So you have to find the takeoff speed, that is the speed which it will have at 94 meters. Is that fine? At point B. Clear? It's very important for you to understand that you need to make these diagrammatic representations. Numericals are otherwise easy, and very important, numericals speak like humans speak. It is just that you need to understand their language. It will take some time initially, but you will be very good at it. Okay? So let us try to see how many variables do I have? 1, 2 and 3. What I don't have is VF. So how do you find VF?
We don't have acceleration.
Yes, we don't have acceleration as well. We don't have VF as well. So we have two variables, right? So the first thing we will do is we'll try to find acceleration. Can we?
Yes.
How?
Delta x equals to VIT plus half of AT squared.
Initial velocity is 0. Final velocity we have to find. Delta x is given, so we have distance as well. If you look at the previous equations that we have, in one equation there are two variables, so definitely we will be requiring two equations, then only we can solve it. Okay? Understand. We have two variables, we have to solve it with the help of at least two equations. Clear? If you are not able to form two equations, we cannot solve this question. Clear? If I write the first equation of motion for you, then the final velocity is equal to the initial velocity plus acceleration into time. Can I use this equation? Why? Because final is unknown, acceleration is unknown, problem, isn't it? Then we have one more, that delta x is equal to v initial into time plus half of, yes, acceleration into time squared, right? Correct?
Yes.
Can we use this equation? Delta x is known, v initial is known, time is known, so we can find what? Acceleration. So when we find acceleration from this, we can use it here and we can find here. Understood? So this is simple, basic understanding. When you have if you have three variables, how many equations should you form? Three equations, at least. If you have four variables, at least four equations. If you cannot be forming, if you will not be able to form four equations, we cannot solve the system of the question. Is that fine? Is it clear? So let us try to solve it with the help of second equation first. Yes. What is the value now? Yes. What is delta x? 94 is equal. Initial is? So this will vanish. So we have half of acceleration, which we have to find. Time is given, it is 2.5 squared. Okay, so this will be 94 multiplied by 2 upon 6.25. Tell me the result. Yes? So the acceleration is 30.08. Tagreed was correct. I lost a croissant now. Okay, acceleration is fine. How about the final velocity? Yes? Final velocity is what? Initial is 0, so this will again vanish, we don't need it. Acceleration into time, so it is 30.08 multiplied by 2.5. What is it? 75.2 meter per second. Is that okay? So that is the result. Clear? Any doubt? In the first problems, if you understand, we needed only one equation. Now how many did we use? In a single question we used two. So it is a bit longer question. But you should not be scared of questions. There will be more complexity in the questions. Questions will be more complicated. But they will be clear to you only when you practice these questions very well. Okay? We have time? So, okay. Okay then. Hopefully in the next class we'll be able to just copy this question. Can you please take a screenshot or something so that you solve it at home? This question. It is an athletic panda, okay, and it is running up the mountain. It is athletic. Pandas are not, they are very lazy otherwise. They are cute, but they are very dangerous. Is that fine? Okay then, thank you so much.